So instead of actually graphing the inequalities, sometimes they give you some lines, they show you some shading or identify a region, and then you have to tell them which region that is. Okay, so you can describe it. So first thing you have to identify is the equation of the line. Okay, most of the time there'll be at least one diagonal, so you just need to remember the whole y equals mx plus c business. What does m represent? The gradient, and c is the y-intercept. Good. Choose a point on the area you're describing. Okay, so double check the question, do they want the shaded part or the non-shaded part? So it should be clear. Choose a point on that side, and then you're going to be able to determine which inequality sign or which direction the inequality sign is going to be. Okay. Double check whether it should be one of these signs or one of these. How do we decide which ones it's going to be? One out of the J.
If it's dotted, then it's the first one.
Good.
If it's not, then
Awesome. So if it's dotted line, it's one of these two, and if it's solid, it's one of those boundaries. So if I want to identify the shaded area, firstly I need to find the equation of this line. So the easiest thing to find is obviously the y-intercept. So I know it's going to be y equals mx plus 2. I'm now going to find the gradient of my line. So I'm going to, do we remember how to find the gradient of a line?
y is over 1.
Y is over 1, but how, what do you do?
2 over 1. You count y2 minus y1 over x.
Okay, yes, I'm being told lots of information here. Essentially, if you have the actual diagram in front of you, though, so in case you'd be using that if you had 2 points, 2 coordinates. So you can obviously find 2 coordinates, or you can literally just look at this and say, right, oh gosh, I don't go through that point, and you find another good point it goes through, and it doesn't really matter where. I'm going to choose this point down here. Okay, that's my random 2 points. You can choose any. I would suggest that you're only going to be choosing points that cross on the intersection. Do you remember we talked about this before? So where they actually would cross at a coordinate. Don't try and count halfway along or assume it's a third or whatever it is. Okay? So from here to here I'm going down 1, 2, 3, 4, 5, 6. I'm going across 1, 2, 3. So I know that's a negative 6 over 3 gradient. What must you always do with gradients in it? What would I always have to do with this value? Simplify it to be negative 2. Lovely. So then that's going to be put into y equals negative 2x plus 2. So that's the equation of the line. So I now need to establish which side that I'm interested in. So I'm going to choose a coordinate on the shaded side. Go with small, easy numbers. Okay, which coordinate do you think I'm going to pick?
0, 0.
Yeah, I am. You could pick any point. Again, as before when we were choosing which side to shade, don't choose something on the line. Okay, so I'm going to choose 0, 0 because that's nice and easy to substitute in. So I've got 0 equals negative 2. Oh, actually, I don't want to what am I doing? I'm trying to start with where it should be. So 0, negative 2, lots of 0, plus 2. So 0 and 2. 0 is greater than or less than? Less than. Is it going to be a less than sign, or is it going to be a less than or equal to? Okay, so then my final answer is going to be y is less than or equal to negative 2x plus 2. Understanding?
So we do all of that, then identify.
Yeah.
Is it meant to be like an equal sign between 0 and negative 2?
Or is it time again? Well, I can think like that because I'm actually substituting values in. It's not all equal to, but my equation would have Yeah, so, well, this one I was just trying to decide which one. Yeah, you can stick that back in up there. But remember, that was my working to decide which direction it was going to go.
Oh,
So officially, mathematics, I shouldn't really write or equal to, because it's not, because I actually use numbers. But here I must make sure I keep it in there. Okay? Next one. So sometimes, as I said the other last lesson, sometimes if you leave it blank, we're asked to shade more than one inequality. And you shade the side, so in other words, you're going to shade the side you don't want. Okay? Identify with R the area enclosed by the following. Okay, so we've got three different things that we need to draw and do. You see? Okay. So we are drawing three different lines, and we are leaving the middle portion blank. Okay. So first things first, we've got x is greater than or equal to 1. So we're going to draw the line x equals 1. Okay, when we've got x equal lines, which way do they go? Okay, vertical, so it's going to go through 1. Is it going to be a solid or a dotted line? Solid. So we're going to draw a solid line through 1 on the x-axis. Okay, the next one is y is greater than 1. So again, we're going to draw the line y equals 1. So there's no crisis here because it's the opposite. So we've got a y equals line, so that's going to be a horizontal one. Is this one going to be dotted or solid? Dotted. Okay. The final one, we've got x plus y is less than or equal to 3. What do I have to do with this expression first before I can draw it? What format should it be? Yep, y intercept form. So I'm going to move my x across, so I've got this as now y equals negative x plus 3. So that tells me I've got a y-intercept of 3, and I have a gradient of negative 1. So that means I'm going down 1 across 1. Down 1 across 1. And I'm going to draw a solid or dotted line. Solid. Now, it is generally the case when you're drawing three lines like this and asked to find a region that your three lines are going to be crossing. You're going to end up with a triangle, obviously three lines which form a triangle. So even deciding which of these sides that you should be interested in, where do you think region R is, just by looking at this diagram? Where do you think region R might be, if it has to be enclosed by water? Yeah? No. There's a little triangle in here, yes? People happy with that? Can we see that there's a little baby triangle there? We just double check though. X has to be greater than 1. So is R in the section where x is greater than 1? Yes. Is it in the section where y is greater than 1? Yes. And let's assume that's in the section where x plus y would be less than 3, because if it hits both of those other two, then it's very unlikely it's not going to hit that one. Okay, so we could do that. We could then also just shade the outside to make it clear that that's the R we're interested in. The key thing with shading inequalities or identifying inequalities is making it clear to the person marking it which bit you're interested in. If it's asked you to label something R, please don't forget the label, because you will lose a mark if you haven't done that. Okay? So just make sure it's clear to the marker. If you shaded it and you think, oh my gosh, I didn't mean to shade that side, don't worry about it, but just make it clear to the person marking it that that's what you're interested in.
Even if you don't ask us for R, you can put that in there.
Sure, definitely. Yeah, label it with something and make sure that say that's the bit you're interested in. Okay?